All right, in this video, we are going to talk about the special addition rule. In the previous video, we talked about the general addition rule. So the thing about the special addition rule is if you can use it, you probably want to use it. It's easier to use than the general addition rule. The trouble is with the special addition rule is that it doesn't always apply to the situation. So you can't use it all the time. But when you can use it, it's just a lot easier to use. All right, so the special addition rule says if A and B are two mutually exclusive events, then the probability of A or B equals the probability of A plus the probability of B. So remember what two mutually exclusive events means. That means events A and B cannot both happen at the same time. So just for example, can you roll on a standard die? Can you roll both one die? Can you roll both a 1 and a 6 at the same time? The answer is no, you cannot do that, right? The upper face is either a 1. If it's a 1, well, then it's not a 6, right? And if it's a 6, it's not a 1. So those two events can't happen at the same time. So those are mutually exclusive events. And so if your two events are mutually exclusive, there's no overlap between them, so there's no need to subtract off the probability of A and B because the probability of A and B both occurring is 0, right? So really, right, if the events are mutually exclusive, then this big thing right here is a 0, right? And so you can just ignore that. There's plenty of times, though, where that's not going to work, like in this problem in 4.98, right? That was in the previous video. You can't use the special addition rule in there. All right. Oops. All right. So that's the special addition rule. Okay, so let's take a look at an example here. All right, so this is example 488, and it says the state of Texas maintains records pertaining to the economic development of corporations in the state. From the Economic Development Corporation Report published by the Texas Comptroller of Public Accounts, we obtain the following frequency distribution summarizing the sales tax receipts from the state's Type 4A corporations during one fiscal year. All right, and it says if one of the corporations is selected at random, find the probability that the receipts are either less than 50,000 or at least 500,000. All right, so let me write that down. We want the probability that the receipts are less than 50,000 or the receipts are at least 500,000. All right, so here's what we want to calculate. So this would be like our event A right here, less than 50,000 or at least 500,000, okay? And they want us to calculate the OR of two events, right? So the first thing we're going to have to decide is, do I have to use the general addition rule or can I use the specialized addition rule? And so the rule is, right, is that are these two events right here, are they mutually exclusive? You have some receipts, right? Is it possible that they are less than $50,000 and also at the very same time greater than 500,000? And the answer is no, they are not, right? You can't have less than $50,000 and then also at the same time have $50,000 or more, right? At least 500,000 rather, right? That's impossible. So these events are mutually exclusive. So in this case, right, we can use the specialized addition rule. All right, in the specialized addition rule, it says that's equal to the probability that it's less than 50,000 plus the probability at least 500,000. All right, and we don't have to subtract off anything, any overlap, because there's no overlap between these two. Okay. All right, and then now we would just go calculate these two events here, the probability of these two events. All right, so let's see here. I'm just gonna add these up off camera. Actually, I can pull these up here. It won't be too bad. All right, so we're gonna have to add all of these up. 25 plus 23 plus 21 plus 11 plus 34 plus 44 plus 17 plus 32. So I get 207 on that one. So that means that I'm going to have something over 207 here plus something over 207 here. All right, so at least let's go with less than 50,000. So that would be less than 50,000 would be right here, right? We would add these up. So that would be 25 plus 23 plus 21. So 69. So the probability that the receipts are less than 50,000 would be 69 over 207. Oops, no, that's not right. Sorry, messed that up. Let's see. So here, I counted these. I just noticed that I counted too much in there, right? So these two right here. So that'd be 25 plus 23, right, which is 48 on that one. Okay. Let's see here. All right. Okay. Next up is at least 500,000. Okay. All right. So that would be at least 500,000, right? So 500,000 or more, that starts right here. So down here. And you can see, right, with these two events, there's no overlap, kind of how there was before. Okay. All right. So that would mean that on the top number for the probability, I'd have what, 49 there, right? If I add 17 plus 32. So that would give me a 49. All right, and then add those two together, I get, is it 97? 48 plus 49 would give me 97, right? And I just keep the denominator the same. So I get 97 over 207 for that probability, okay? All right, so you can see that's the special addition rule when the events are mutually exclusive, and it's a little bit easier because you don't have to do the subtraction there. All right, next example is about oil spills. This one says, the U.S. Coast Guard maintains a database of the number, source, and location of oil spills in U.S. navigable and territorial waters. The following is a probability distribution for a location of oil spill events. All right. It says, if an oil spill is selected at random, find the probability that the spill occurred in a lake or harbor. All right, so I'm going to write that as probability of L for lake or H for harbor. Okay. And so here, right, I can see that there are some lakes The Great Lakes, right? Other lakes. And here are harbors, right? Okay. So going to the addition rule, I have to decide, okay, am I going to use the general addition rule or the addition rule, right? I'm calculating the or of these two events, so I'm going to probably be using one or the other. So I have to ask myself, hey, is it possible that an oil spill occurs in a lake and also at the same time as a harbor? Well, the answer here is no, right? Because generally speaking, a harbor, right, it would be in the ocean, and a lake is not in the ocean. Okay, so that would mean that L and H are mutually exclusive. And if you're not up on geography or something like that, you don't have to worry too much about that. It's not going to be something where you have to know a ton about some other subject in this class, so that at least on the quizzes or tests. All right, so L and H are mutually exclusive. So that means I can use the specialized addition rule, and so that's going to be the probability of L plus the probability of H, okay? All right. So let's go look back over here. And so notice, right, in this diagram over here, what we've got, right, is the probabilities. We don't have the frequencies, right, the counts. They give us the probabilities, right? And so when we're looking at here, we have two lakes, right? We have Great Lakes and we have other lakes, right? So those probabilities. For harbors, though, we only have this probability here. So the probability of H, right, is 0.161. That one's pretty straightforward, right? We can just look, and there's only one of those listed there. So the probability of H is 0.161, and that is just looking from this chart right here. On the other hand, though, Great Lakes and other lakes, right, we don't have the counts here, right? And so it's not as simple for Great Lakes, right? The only lakes we have are Great Lakes and other lakes, right? So the probability of L, the probability that the oil spill was in a lake, is the probability the same as was it in a Great Lake or in, I'll put OL for some other lake. So this probability that we're after, the probability that an oil spill occurred in a lake, is equal to the probability of this event right here. So we have another OR probability that we are going to have to calculate, okay? All right, so the thing then you have to ask yourself is, hey, are these two events mutually exclusive? Can you have an oil spill that occurred in a Great Lake and at the same time occurred in some other lake? And the answer is no, you can't, right? Because of the way this is organized, the Great Lakes are counted here, and every other lake besides the Great Lakes, even though it's not super explicit, but that's what it implies, right, is here. So you can't have an oil spill that's in the Great Lake and some other lake that's not a Great Lake at the same time. Okay, so these are mutually exclusive again, and we can use the special addition rule right here. All right. And now the probability that the oil spill occurs in a Great Lake is 0.020. And the probability that it occurs in some other lake, right, is 0.002. And so when you do that, you get 0.022 on that one. Okay, so now going back to the original problem that we had, we know that the probability that the oil spill occurs in a lake is 0.022. The probability that it occurs in a harbor, right, is 0.161. And then adding those two together, we get 0.183. So what we get, yeah, 0.183. That looks right to me. 38, yes. Okay. All right, so this is the answer on this one. I do want to say one thing about this, right, and that is the reason why we had to go through and do this is because part of the reason is because they gave us probabilities. Had they given us counts, right, the number, right, we would have just had, we could just add up the counts of all the lakes that occur in here as well. And really, you can see we're kind of doing that anyway, but you have to be a little bit careful about doing that when not to count twice. Okay. All right. Let's see. I think we have one more example here. Yes, one more example. All right, and that's 4.92. In 4.92, it says, according to the Religious Landscape Survey, sponsored by the Pew Forum on Religion and Public Life, a distribution of religious affiliation among U.S. adults is as shown in the following table. And it says, find the probability that the religious affiliation of a randomly selected U.S. adult is Catholic or Protestant. Okay, so we want to calculate the probability that a randomly selected person is Catholic or Protestant. I'm going to spell out Protestant because it starts with a P and looks like the symbol for probability. All right, so we want to calculate the OR of these two events, right? And so what we have to do is ask ourselves, are these two events mutually exclusive or not? All right, so that's always going to be the question, and the answer to that question is going to tell us whether or not we can use the special addition rule, which is a little bit easier, or if we have to use the general addition rule. All right, so what we have to ask ourselves, are these two events mutually exclusive? Can a randomly selected person be both a Catholic and a Protestant? And in general, you would probably say that the answer is no to that, right? Usually people are just one religion, right? Although, who knows? There might be people out there, but for the purposes of this, we'll say that no, you can't do that. You've got to select one or the other. All right, and so therefore, Catholic, right, and Protestant would be mutually exclusive. There's nobody that is both of those two denominations or religions, however you want to say it. Okay? So they're mutually exclusive. So since these events are mutually exclusive, right, we can use the special addition rule. The special addition rule says that's just going to equal the probability that a randomly selected person is Catholic plus the probability that a randomly selected person is a Protestant. All right, and so now we're just going to go back and look at those and see what we can come up with. All right, so here they give a relative frequency, right? And so these are going to be probabilities, right? Remember, how did you calculate the relative frequency back when we were doing that in chapter 1 or 2? I can't remember which one it was, but what we did, right, was we added up all the frequencies and then we divided each of these by the frequencies. So really, that's just a probability, right? So the probability that somebody is Catholic, a randomly selected person is Catholic, is going to be 0.239, okay? And then plus the probability that somebody is a randomly selected person is Protestant is 0.513. Right, so that's what it's going to look like. And so now we would just add that together, and that's going to be 2, 5. 752. Yeah, that looks okay. All right, and that is our answer on this one. All right, and that's it for this video. In the next video, we will talk about calculating the complement of an event.